Suppose a population of a town is growing at 4.5% per year. If the current population is 1,000, when will the population reach 40,000? Solution. The population is growing at a constant percentage rate. How do we find a new population here? Let's call the new population by P. P is going to be a function of T, of time. So what we'll do is multiply the current population, which is 1,000, times the 1 plus the growth rate, to the power of t. Right, so that will give us 1,000 times 1 45,000ths to the power of t. Okay, so this function is our population function. Now, how do we find out when the population will reach 40,000? Well, this is actually an easy problem for the next section, for section 3.3, when we talk about logarithmic functions. We use logarithms to solve exponential functions, exponential equations. In this section, we can solve this problem using graphing, using a graphing calculator. How exactly do we do this? Well, at some t, at some time, the population is going to equal to 40,000, right? So 40,000 is going to be equal to our function 1,000 times 1 45,000ths to the power of t. And what we have to do is solve for t. Here's a graph of the exponential function. This graph is the graph right here. The curve here is the exponential function. Now the constant line is at 40,000. This is what we want our population to be. Right. So the idea is to find some value t, for which the population is equal to 40,000. And this is going to be our solution. Some value of t that's right here is going to be our solution here. Okay, so let's use a calculator to solve this, right? So we're looking for the intersection of two lines, with two curves. One is the exponential curve, and the other one is horizontal line. So I'm going to turn on my calculator, and I'm going to input the two functions here. 1,000 times 1 and 4,500ths to the power of t, or we'll call it x in this calculator, and also 40,000. Now we have to change the window here. The window that we'll use here, the x value is are going to be between 0 and 100. The x scale is going to be, we'll go in tens on x-axis. The y values are going to be between 0 and, let's say, well, in this case, in this picture here, it's 80,000. Let's do that. Let's do 80,000. And the y scale is going to be in 10,000. So let me graph this. Alright, so this is the same picture on our calculator looking for this intersection. To look for the intersection, we have to go into the calculate menu, right? So this yellow menu here. And anytime we need to go in the yellow menu on the calculator, we have to use the second button. Second, we're going to calculate. We're looking for the intersection. It's option 5. The calculator is going to take us through a prompt. What is the first curve? In this case, this is our first curve. It's displayed in the top left. I'm going to press enter. Our second curve is 40,000. Right, that's our second curve. Press enter. And my guess for the intersection, I'm just going to scroll to that. Right, so intersection is somewhere here. We don't have the actual intersection until it says intersection here. So I'm going to press enter. intersection is 83 and 8/10, so approximately 84 years. So this value of t is, we said it was 84. Alright, so the solution here, the population of this town will be 40,084 years from now. When we talk about logarithmic functions in the next section, we will learn how to solve this equation here. This equation is actually easily solved using logarithms, right? We're not going to need to use a calculator to solve this equation in the next section.